Today's lesson is 2.1, Solving Systems by Graphing. A system of equations is two or more linear equations. In this first lesson, we're going to go ahead and just see two of them. But as the unit goes on, we will add three equations with three unknowns. A solution, which is an answer, is where the graphs intersect each other. A system can have the following types of solutions. It could have one solution, the point of intersection of the two lines. It could have no solution, my lines are parallel and they're never touching, or they could have infinitely many solutions where my lines are just graphed right on top of one another because they're the same line. To go ahead and solve a linear system, there are three steps for us to keep in mind. The first thing that we need to do is we need to rewrite each of our equations in our slope-intercept form. I write too big. If you remember, this is our y equals mx plus b. We need to write it in that form. Once we've done that, we can go ahead and we can graph each line independently. There we go. Meaning we graph the first line and then we go ahead and we graph the second line. The last thing we need to do is identify the point of intersection because this is our solution. All right, so we're going to rewrite it in slope-intercept form, y equals mx plus b. We're going to graph each line independently, and we're going to go ahead and identify our point of intersection. We have three examples today. Let's go ahead and get started. In our first example, what I'm going to do is I'm going to go ahead and label the graphs, the two equations, as equation 1 and equation 2. It's not necessary per se, but it sure does come in helpful to make sure that you don't graph the same line. Oops, held that too long. You don't graph the same line more than once. Okay, so I've even gone ahead and coded them for you. This way we know which line is which when we look at the graph. That's the reason for the color coding. All right, let's go ahead and take a look at graph number 1. Now, the nice thing about equation number 1 is that it seems to already be in the y equals mx plus b form. Watch this. I'm going to go ahead and write y equals mx plus b underneath. And I can very easily see that m, my slope, is 1/3, and that b, my y-intercept, is -2. I could just come around here and circle them, right? There's m, there's b. All right, remember that m shows you how to move, which is why I believe we chose the letter M as mathematicians. Probably not, but we can dream, right? Remember the top number, the numerator, tells you how to move up or down. Since it's positive, it's showing you how to move up. And the bottom number, the denominator, is showing you how to move left or right. Since it's positive, it is telling me to move 3 to the right. Now remember, I can reverse these. I can go back to my beginning and reverse these by simply going the opposite direction, down and to 1 and to the left 3. All right, let's go ahead and start graphing. Remember, we begin at the beginning. And that's why I like to think they use the letter B. So let's put a point on -2, and then let's simply move up 1 and 3 to the right. Here's our next point. There we go. And we can continue this pattern until we run out of space on our graph. Perfectly fine amount of lines, but we want to make sure that our intersection is an exact point and we have it completely graphed. So I know that the line is going to look something like this. I could draw it much better, I know. But I'm not exactly sure where the points are down here in this third quadrant. So I want to go ahead and I want to go back to my beginning, and move in the opposite directions, one down, three to the left. So one down, three to the left, and then I'm just going to repeat the pattern. One down, three to the left. Now I have completed my graph. It is much better for the intersection point. All right, I'm going to grab my ruler and I'm going to connect them together. Now this program that I use is a ruler. There we go. Let me kind of move it. Perfect, there we go. Show that my line continues infinitely in both directions. That one was easy peasy lemon squeezy. Let's go ahead and look at equation number 2. Now the problem with equation number 2 is that y is not alone. Okay, let me go ahead and with my purple shade in that y is not alone. So what I need to do here is that I need to solve this equation for the variable y. I need to get the y value alone. Remember that when a number is being placed right next to a variable, the letter y in this case, that there's multiplication hiding in between them. To undo our multiplication, we're simply going to do the opposite, which is divide by 3. Everybody over here is going to get divided by 3, but I'm going to choose to do it separately because I need to see my slope and I need to see my y-intercept. So now I have y equals 2 divided by 3, negative 2 divided by 3 is going to stay negative 2 divided by 3. And then 3 divided by 3 is going to become 1. All right, now I can go ahead and say y equals mx plus b, and I can see that my m in this case will be the negative 2/3. I like to keep the negative with the numerator, and I like to keep the denominator positive, but it doesn't matter. It just has to be with one or the other. And I can see here that b is 1. All right, so remember I'm going to move down 2 and 3 to the right because negative is down. So let's begin at the beginning, which is positive 1 right here. And let's use our slope, to go down 2 and 3 to the right. Down 2 and 3 to the right. There's my next point. And if you notice, I've already got my intersection. So even though I should probably go back to the beginning, and move in the opposite direction, I don't have to because I can already see that they're mixing right here. They're going to intersect right here. So if I wanted to, my dog wants to go outside. I could go ahead and do that, but I don't have to. There we go. Perfect. Where is my solution? Right here. This right here is my solution. I would write it as an ordered pair. Let me see, where do I have space? It is 1, 2, 3, positive 3, comma, negative 1. There's my solution. All right, let's go ahead and take a look at the next example. Remember, you always want to label them equation 1, equation 2. This is so that you don't do the same graph more than once. All right, it looks like I'm going to have to do some moving for this one as well, because as I can tell, the y is not alone. To simply get the y alone for this one, all I have to do is move the x to the other side. Since the x is being added to the y value, it's that addition that I need to get rid of. Now I need to be careful because that is a negative x. So if I were to subtract From a negative, I get more negativity, right? Negative minus negative is more negative. So instead of subtracting, I want to go ahead and add the x to the other side. Now, it is correct to leave it in this order. However, I don't like to. I don't like to leave it in this order because we always think of this. And what a lot of people do is say, well, there's my beginning and here's my slope. And that is not correct. So I like to put x first and then plus 1. There we go. I'm going to go ahead and put my y equals mx plus b underneath. And I think I'll use my blue this time. My slope. Ooh, this one's tough. Take a look. Here's my m. There's nothing there. But remember, when x is by itself, there's an invisible 1. So my slope is 1. Whenever my slope is a whole number, I can think of it as being a fraction, as simply being over 1. A whole number over 1 is a fraction. And so this slope is telling me move 1 up and 1 to the right. And my y-intercept is, of course, the positive 1. All right, let's begin at the beginning. Let's begin at the beginning, positive 1. And then we're simply going to move 1 up and 1 to the right, 1 up and 1 to the right, 1 up and 1 to the right. And we're just simply going to follow that pattern. Okay, so let me add the actual points. There we go. We can go back to the beginning. Oops, we can go back to the beginning and we can go opposite, down 1 and to the left, 1 down, 1 to the left, 1 down, 1 to the left, down, 1 to the left, until we end up at the end of the graph. And the reason for this, remember, is for our intersection point. We want it to be as precise as possible. It was so easy to find the answer the last time because we had them all lined up. There we go. All right, let's see if graph number 2, equation number 2, is going to be as nice. All right, I can already see that my y is not alone. There's a pesky 2 hanging around in front of it, and that x is there as well. I got to get rid of the add or subtract first. This time it is a positive x, so I'm going to go ahead and subtract it. Now be careful. You're going to want to go ahead and write this as negative x plus 8. Remember, you want to keep that y equals mx plus b form. And that's just for helping you with graphing. That's just for helping you with graphing. Remember that whenever there's a number in front of a variable like the letter y, we're hiding multiplication in between. And to get rid of it, we're simply going to divide by the number. Everybody gets divided. There's an invisible 1 hanging out there. 1/2 x plus 8 divided by 2 is 4. I don't have the space, but let me see if I can squeeze it in there. There it is, y equals mx plus b. M is going to be our negative 1/2. We're going to go ahead and move 1 down and 2 to the right. And our beginning is going to be the positive 4. All right, here we go. So let's begin at the positive 4. 1, 2, 3, 4. And let's go ahead and move 1 down and 2 to the right. 1 down and 2 to the right. I've already got my intersection. There's no need to go back and do it the opposite direction. Let's just grab our ruler and create our line. Here is our solution. Ooh, you know what? Let's put it like this. There is our solution. It is 1, 2, comma, 1, 2, 3. 2, comma, 3. There we go. All right, I have one last example for you. Let's go ahead and see if we can figure this one out. All right, let's go ahead and take a look at equation 1. looks just like the one we just did. I'm going to go ahead and highlight that y because we need to get it by itself. I'm already thinking get rid of that add or subtract. That's our x. It's a positive x, so let's go ahead and subtract it. Remember, you want the x value to be first for your y equals mx plus b. So you're going to put negative x plus 12. That's the same thing. Remember, when there is a number in front of the variable, the letter y in this case, there's multiplication hiding in between. So you're going to want to go ahead and divide every term by 4 so that y is completely alone. There's that invisible 1 hiding there, so I have a fraction of negative 1/2 plus 3. Here is my y equals mx plus b. I don't know about you guys, but it's a lot easier for me to see my slope when I do that underneath. My slope is negative 1/4. Remember, I'm bringing the negative to the numerator, to the top, so that I'm going to move 1 down and 4 to the right. My beginning point, or my y-intercept, is going to be this guy right here, positive 3. So let's go ahead and start at positive 3. 1, 2, 3. And then we're going to go 1 down. Let's put the point. There we go. And we're going to go 1 down and 1, 2, 3, 4 to the right. 1 down, and I can't go anymore. So 1 down, 4 to the right, and I'm going to have to go back to the beginning, and I'm going to have to go in the opposite direction. So I went back to the beginning. I'm going to go up 1 and 4 to the left. What this does is it makes the 1 positive and it makes the 4 negative. So 1 up, 1, 2, 3, 4 to the right. There we go. Let's grab our ruler and connect them together. Nope. Oh, almost. Perfect. There we go. All right, graph equation number 2. Ooh, equation number 2. This one looks harder than anything we have seen so far, but I think we've got it. I think we have enough experience in our toolkit to get us through this. There we go. We're going to get that letter Y highlighted, oops, so that we get it by itself because that is our goal. All right. All right, just like before, I see that there's the addition of that x value, which happens to have a 7. It's not just x, it's 7x. So I'm going to go ahead and move that to the other side because I must get rid of the addition or subtraction first by doing the opposite. It's positive 7x, so I'm going to go ahead and subtract it. Remember, you're never going to be actually subtracting the numbers that you see, 12 and 7. We're not going to go and put negative 12 minus 7 in a calculator. No, no, no. We're going to put the x one first. And then since it is a negative 12, I am going to go ahead and say minus 12 this time instead of positive 12. I need to remind my brain that I'm solving for the variable y. Y is the variable, the letter that I want to get by itself. Whenever there's a number hiding in front of it, or in front of it, there's multiplication hiding in between. So let's go ahead and divide. Everybody gets divided by 4. Well, 7 divided by 4 is going to say 7 divided by 4. It's simply just going to be negative because the 7 is negative. And 12 divided by 4 is 3, so it's going to become minus 3. Let's go ahead and remind ourselves that this is mx plus b so that we can find our slope. Let me put it up here. As you can see, very easy to identify that our slope is negative 7/4. Remember, we want to put the negative with the numerator. We're going to move down 7 and 4 to the right. And we're going to begin at the beginning, and our beginning point is b, negative 3. All right, let's go ahead and begin at our beginning, negative 3. 1, 2, 3, there it is. Remember, you always start from the origin right here at 0, right? There we go. And we just count down 3. All right, let's see. 1, 2, 3. Uh-oh, I can't go down 7. So I guess I should have changed this. Let me grab my eraser here. I'm thinking what I'm going to have to do, oops, is put the negative here and make the 7 positive. So let's go up 7 and 4 to the left. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. There it is. Right there. That is enough points. I don't think, yeah, I cannot go any more. I can't count up 7 and to the left 4 anymore. So that's as close as I'm going to get. Just make that as straight as we can. Perfect. Because there's our solution right there. There's our solution. Maybe I should write that in a different color. Remember, you've got to tell me the x and the y value. So remember, this is your x. We're in the negative, so I'm just going to count over until I've got it. I think it's at -4, comma, and then we're in the positives, 2, 3, 4, it looks like. -4, +4.